The apparatus here exemplifies the world's simplest practical electrical circuit, similar to the one used to operate car headlights. A copper wire, this one with white plastic covering, goes from one of the terminals of the battery on the left to a bulb, where the wire connects to a very narrow filament of tungsten wire within the glass. The other end of the tungsten filament connects to another copper wire, this one, as it happens, being varnished copper wire, and this passes by a somewhat elaborate route that I will explain shortly to this crocodile clip. If I attach the clip to the other terminal of the battery, the bulb filament, because of the current, gets so hot it glows. If I connect it across both the batteries, it glows brighter. The electric battery was invented in 1800 by the Italian Alessandro Volta, and a circuit similar to this one, including a primitive battery and a primitive electric lamp, was constructed by the English scientist Humphrey Davy in 1802. I will now turn the current off by disconnecting the crocodile clip. Now, as to the somewhat elaborate route taken by the varnished copper wire. I will use this arrangement to demonstrate the great leap forward made in 1820, 200 years ago, the discovery of the relationship between electricity and magnetism. You can see there is a stretch here where the wire runs in a straight line a centimetre or so above the painted wooden base of my apparatus. The 1 centimetre gap between the wire and the base means that I can neatly insert beneath the wire a magnetic compass. I have already arranged the straight stretch of wire to run north to south. So when I put the compass needle underneath it, the wire and the compass needle are parallel. The copper as such does not disturb a nearby compass needle. The red painted end of the compass needle naturally points north under the influence of the Earth's magnetic field, and the other end south. But if I make the current flow not only does the bulb glow, but the red painted end of the needle moves away from the north to point somewhere between north-northeast and northeast. I'll do that again. Compass needle pointing north, current flowing, and compass needle not pointing north anymore. If I use both batteries instead of just one, the rotation is somewhat increased. And if I reverse the connections of the crocodile clips to the batteries so the current flows the other way, the red end of the needle now rotates towards the northwest instead of to the northeast. Now, this experiment, rotating a compass needle by means of an electric current, was first done by a Danish scientist, Hans Christian Oersted, 1777 to 1851. He privately printed and disseminated a pamphlet describing his work in July 1820. So I am doing my reconstruction of his experiment in the bicentenary year. Here is a probably fanciful picture of Oersted demonstrating the effect to his friends or colleagues. Here is the title and opening paragraph of his pamphlet, which you will note is in Latin, presumably because he knew that few people read Danish. In contrast, English and French scientists of the period published in their own living languages. The Latin was not that convenient for foreigners, but soon it was translated into more accessible languages, English, French, German, and Oersted's work took the scientific world by storm. Oersted's experiment was scientifically exciting because it proved that electricity and magnetism were related. But his experiment and my modern reconstruction here are, from a practical point of view, just toys, merely moving a delicate compass needle a little bit. But soon after Oersted, ways were found of achieving much stronger magnetic forces from electric currents. An early commercial application was the electric telegraph. In the form invented by the Americans Samuel Morse and Alfred Vail, the sender of the message operated a switch, usually called a Morse key. An electrical current went a long wire supported on poles to a remote receiver in which a piece of iron with a pen attached was moved magnetically, writing a code of dots and dashes, Morse code, onto a moving paper strip. Electric motors were soon devised, too, becoming commercially important around the end of the 19th century. Our present world, the global village of communication anticipated by the telegraph, and the progressive adoption of electricity for motive power in the factory, in the home, for most modern railways, and increasingly in the motor car. These things go back 200 years to the experiment with the current carrying wire above the magnetic compass needle.